Hi, welcome back to my class in Algebra. For today, we will take up radical expressions. These properties of radical expressions are used to simplify algebraic expressions that contain radicals and in rationalizing expressions, especially rational algebraic expressions, where the numerator or the denominator contains some radicals. And to rationalize an expression means to remove the radical signs. We start with the first property of radicals. The first property says the nth root of a to the m is equal to a raised to the power m over n. At the left-hand side of this equation, this expression at the left-hand side of this equation is called a radical expression. The symbol is known as the radical sign. And the number n here is called the index of the radical sign. And the expression inside the radical sign is known as the radicand. In this first property of radical, a to the m is the radicand. N is the index of the radical sign, which indicates the nth root of the radicand. And this symbol here is the radical sign. According to this first property of radical, the nth root of a to the m equals a to the power m over n, or the exponent of a is a rational number m over n, a ratio of the integers m and n, where the numerator m is the exponent of a and the denominator n is the index of the radical sign. We take some examples to apply this first property of radical to simplify algebraic expressions or to remove the radical sign. If you want to remove the radical sign from this expression, apply the first property of radical. The index n is 3, your a is x, and your m is 5. And by this property, the nth root of a to the m is equal to a raised to m over n, where a is x to the power, the exponent of x will be a fraction, or the numerator is the exponent of a. In this example, the numerator in the exponent of x is the exponent of x, 5. And the denominator of the fractional exponent of x is the index of the radical sign, 3. Thus, we have removed the radical sign and we express this radical expression as in exponential form, where the base is x and the exponent is 5 over 3. Where 5 is the exponent of x in the radicand and 3 is the index of the radical sign. Again, we apply the first property of radical to remove the radical sign and express this radical expression in exponential form. The base of the radicand is 2x minus y. 2x minus y is your a in the first property. The exponent m is 2 and the index of the radical is 5. Hence, the fifth root of the square of 2x minus y is equal to 2x minus y, that's your a, raised to the power m. M is 2. Divide by n is the index of the radical expression, which is 5. Hence, the fifth root of the square root of 2x minus y is the same as quantity 2x minus y to the power 2 over 5. And using the first property of radical, we have removed the radical sign. And we have expressed this radical expression in exponential form or using exponential notation. We take another example. Now we can simplify this radical expression using the first property of radical. The radicand here is x to the 4, y to the 8. The index is 2, which means we have the square root of x to the 4 multiplied by y to the 8. If the index is 2, which indicates the square root, we no longer write 2. We only write the index if the index is more than 2, that is from 3, 4, 5, and so on. But if the index is 2, as in this example, which indicates a square root, this indicates a square root, but it means that the index is 2. We no longer write the index 2. It's understood that if the index is not written in the radical expression, the index is 2. And the index 2 indicates the square root of the radicand. Now we can write x to the 4, y to the 8 as a single quantity. And we write this as the square root of quantity x to the 4, y to the 8 raised to 1. Again, we take this product x raised to 4, y to 8 as single quantity raised to the power 1. And I wrote this in this form so that we will know what is the exponent m. Now the exponent m is 1 and the base a is x to the 4, y to the 8. And the index n in the property is 2. Hence, by this first property of radical, this is now equal to a. Our a is the product of x to the 4, y to the 8. And that will be raised to some exponent, m, where m is the exponent of a. And in this example, our m is 1. Divide by or over n, where n is the index of the radical sign. And the index here is 2. As I said, if the index is not specified, it's understood that the index is 2. That indicates the root of this quantity. Divide by 2. Now, to further simplify, we apply properties of properties of exponents, which we have taken earlier in the previous lessons. Here we apply the property of exponent that says the product AB raised to the exponent n is the same as A raised to n multiply by b raised to n. Thus, in the product, each factor a and b is raised to the same exponent n. And we apply this property of exponent to this. X raised to 4, we raise to 1/2. Multiply by y raised to 8 raised to 1/2. To simplify further each of these factors in this product, we apply another property of exponent that says if an exponential notation a to the n is raised to another exponent m, a to the n raised to m is equal to a raised to the product of n and m. The exponents are multiplied and multiplied by m. We multiply the exponents. So here we multiply the exponents 4 and 1/2. X raised to the product of 4 multiplied by 1/2, that's 4 over 2. We apply the same property of exponent to this y raised to 8 raised to 1/2, and it's equal to y. Multiply the exponents, 8 multiplied by 1/2, that's 8 over 2. Now we simplify this fraction. We have x raised to 4 divided by 2 is 2. Multiply by y raised to 8 divided by 2 is 4. Thus, using this property of radical and these properties of exponents, the square root of x raised to 4 multiplied by y raised to 8 is x squared y raised to 4. We now state the second property of radicals. The nth root of a multiplied by the nth root of b is equal to the nth root of the product ab. Now, using this property, we can write the product of two radical expressions as long as they have as long as they have the same index n. And it does not matter if they have different radicand. In this expression, the radicand is a, the index is n. In this expression, the index is the same n, but the radicand is different. If we have a product of two radical expressions with the same index but different or the same radicands, you can write this product with a single radical sign and with the common index n, and the radicand is the product of the radicands in the original given radical expressions. We take some examples. We now show that the square root of x multiplied by the square root of x simplifies to x using the second property of radical. Again, as I said earlier, if the index is not specified, it's understood that the index is 2. So the index of square root of x here is 2, and the index of square root of 2 here is the index of square root of x here is also 2. And in these radical expressions, in this product of two radical expressions, the radicand is the same x. And using this property, the product of square root of x multiplied by square root of x is equal to the common index n. In this example, it's 2 and 2. So we have the square root of the product of AB, the product of the radicands. Here the radicands are the same x. We multiply x by x. But by property of exponent, x multiplied by x is x squared. The exponent of x here is 1. If the exponent is not specified, it's understood that the exponent is 1, as in x. Similarly, the exponent of this x here is 1. So this square root of x multiplied by x is equal to the square root of, by property of exponent, if you have the same base, copy the common base and add the exponents. 1 here plus 1 here is 2. Now we remove the radical sign from this radical expression using the first property we have stated earlier, the nth root of a to the m we further simplify the square root of x squared using the first property of radical, which I have stated earlier. The nth root of a to the m equals a raised to m over n, where m is the exponent of the radicand and n is the index of the radical sign. Here the index n is 2, the exponent m is 2, and the base a is x. Hence, applying this first property of radical, the square root of x squared equals a is x to the power m, m is 2 over n. N is the index of the radical sign, and the index here is 2. But 2 raised to 2 is 1. We get x raised to 1. But if the exponent is 1, we no longer write the exponent 1. And we simply write x. If you have x, it's understood that the exponent is 1. Thus, we have shown that the square root of x times the same quantity, square root of x, simplifies to x. And we did that by applying this property of radical as well as the first property of radical. We simplify this product of two radicals by applying this property of radical. The common index n in this example is 3. Now the radicands are different. In the first radical expression, the radicand is x plus y. In the second radical expression, the radicand is x minus y. But in these radical expressions, the index is the same 3. Thus, we can combine these two radicals using this property of radical. The nth root of a times the nth root of b is equal to the nth root of the product of the radicands a and b. Thus, the square root of x plus y multiplied by, the cube root, 3 means cube root. The cube root of x plus y multiplied by the cube root of x minus y is equal to the cube root. The common index n is 3. So this product is, as one radical expression, is equal to the cube root of the product of the radicands. The product of x plus y and x minus y. Now, if you can simplify the radicand, you do simplify it. And in the radicand, we have the product of x plus y and x minus y. Or we have the product of the sum and difference of two terms. The first terms in the two binomials are the same. The second terms in the two binomials are the same. And the sign between these two binomials differ. One has a plus sign between them. The other has a minus sign between them. So to simplify this product of the sum and difference of two terms, we apply one of the special product rules, the rule for the product of a sum and difference. This is one of the special product rules which we have also taken before. If you missed that lesson, you search for my tutorial video, Art Teaches Algebra. The product of a plus b and a minus b is equal to the square of a minus the square of b. In this product x plus y, x minus y, a is x and b is y. Hence, by this special product rule, the cube root of x plus y multiplied by x minus y is equal to the cube root. The cube root of square of a, our a is x, minus the square of b. Our b is y. Hence, we are able to write the product of these two radicals with the same index but different radicands as a single radical expression with whose index is the common index 3. And the radicand is the product of these two radicands which we have simplified or multiplied using the special product rule. We take another example before we state the third property of radical. We simplify this product, the square root of y. Again, the index is not specified. That's understood that the index is 2. The square root of y multiplied by the square root of y to the power 3 or y cubed. The index is 2 multiplied by the square root of 64 multiplied by y raised to 5. We apply the second property of radical to write this product of three radical expressions as a single radical expression whose index is the common index of these three radical expressions. And the common index is 2. So this product is equal to the square root. The square root of the product of the radicands. The product of y multiplied by y cubed multiplied by 64y raised to 5. Now we apply property of exponent, one of the properties of exponents, to get the product of y, y cubed, and y raised to 5. And this property says a to the n multiplied by a to the m is equal to a to the power n plus m. To get the product of y, y cubed, and y raised to 5, we apply this property of exponent that says a raised to n multiplied by a raised to m. Notice that the base is common a, but the exponents are different. And this can be written as a single exponential notation. Take the common base a and add the exponents of a, n plus m. So here the common base is y. We have square root of y to the power. The exponent of y is the sum of the exponents of y in this product. The exponent of y here is 1, 3, and 5. And the sum is 1 plus 3 plus 5 is 9. And 64 cannot be combined with any other quantity. We simply write 64. Now we further simplify. We write here, we take 64y raised to 9 as a single quantity raised to exponent 1. This is equal to the root of 64 Now I wrote the square root of 64y raised to 9 as the square root of quantity 64 multiplied by y raised to 9 to the power 1, so that we can apply this property of radical, the nth root of a to the m we apply this property of radical that says the nth root of a to the m equals a to the power m over n. To simplify this, the index n is 2, the exponent m is 1, and the base a is 64y raised to 9. Hence, by this property of radical, this square root of 64y raised to 9 raised to 1 is equal to the base 64y raised to 9 to the power m. The exponent of this base is 1. Divide by n. N is the index of the radical sign. The index is 2. Now, 64 is what is known as a perfect square because it can be written as a square of a number, and that number is 8. The square of 8 is 64. So 64 is a perfect square because it is equal to the square of 8. And we write 64 as the square of 8. Now the exponent of y is odd number, and 9 is not exactly divisible by 2. If we write y raised to 9 as the product of y raised to 8 and y raised to 1, this exponent 8 of y is divisible by 2. We are trying to simplify the expression, we are trying to extract the root of 64 y raised to 9. If the exponent of a quantity or base is an odd number and the denominator in this exponent is an even number 2, you take the largest number from 9 that is divisible by 2, and that largest number is 8, and we subtract 8 from 9 and you get the exponent of the other y in the product. We have written y raised to 9 as the product of y raised to 8 and y raised to 1, so that we get an expression y with exponent the 8 that is divisible by 2. To simplify this further, we apply another property, the first property of radical. Again, to simplify this further, we apply a property of exponent that says we apply the property of exponent. The product AB raised to n is equal to the product of A raised to n and B raised to n. Each of these factors A and B of the product AB is raised to the same power n. Although in this example we have a product of 3 factors, 8 squared, y raised to 8, and y raised to 1. And applying this property of exponent, we raise each of these 3 factors to 1/2. Hence, the 8 squared, y raised to 8, y raised to 1 raised to 1/2 is equal to 8 squared raised to 1/2 multiplied by y raised to 8 raised to 1/2 multiplied by y raised to 1 raised to 1/2. In applying this property of exponent to simplify this expression, we raise each of these 3 factors to the same exponent 1/2. And to simplify each of these factors, we apply another property of exponent. The exponential notation a raised to n is raised to another exponent m. And this simplifies to a raised to the product of the exponents n and m. Hence, to simplify this expression, simply multiply the exponents n multiplied by m. And we apply this property of exponent to each of these 3 factors. 8 squared raised to 1/2 is now equal to 8. Multiply the exponents 2 multiplied by 1/2 is 2/2. We also apply this property of exponent to simplify y raised to 8 raised to 1/2. And y raised to 8 raised to 1/2 is y to the power multiply the exponent. 8 multiplied by 1/2 is 8/2. Multiply by y raised to multiply the exponents. 1 multiplied by 1/2 is 1/2. Now 2 over 2 is 1, so you get 8 raised to 1 here, or 8. Multiply by y. 8 divided by 2 is 4. Now, we cannot simplify further this expression y raised to 1 half. And we write this in radical form using the property, this property, the first property of radical. But we now start from the right hand side. A base raised to a rational exponent, m over n, is equal to the nth root, where n, the index n, is the denominator of the rational exponent of a. The nth root of a is the base, raised to m. M is the numerator of the rational exponent of a. So using this property of radical, y raised to 1 half is equal to the nth root, and the index n here is 2, and the index 2 indicates square root. Square root of our a is y, our m is 1. Hence, y raised to 1 half equals the square root of y raised to 1. But I said earlier, if the exponent is 1, we no longer write 1. Y raised to 1 is simply written as y. Thus, the product of square root of y, square root of y cubed, and the square root of 64y raised to 5 is 8y raised to 4 multiplied by square root of y. This is the simplified form of the product of y, square root of y, square root of y cubed, and square root of 64y raised to 5. Now we state the third property of radical. This third property of radical is similar to the second property of radical, except that in the second property of radical, the operation involved is multiplication of two radical expressions. But here, the operation involved is division of two radical expressions, but the radical expressions have the same common index n, but they have different radicands. In this rational expression, this is a rational algebraic expression, but the numerator and denominator are radical expressions with common index n, but the radicand of the numerator a is different from the radicand of the denominator b. But it does not matter if they have different radicands. What is important here is the radical expressions have common index n. If you have a rational expression of this form, where the numerator and denominator are radical expressions with the common index n, it can be written as a single radical expression whose index is the common index n of the radical expression in the numerator and the radical expression in the denominator. And the radicand is the quotient of the radicands in the radical expression in the numerator and the radical expression in the denominator. We take some examples to apply this property of radical. For our first example, we simplify this radical expression. This is a rational algebraic expression whose numerator is a radical expression and the denominator is a radical expression. And to simplify this rational algebraic expression, we apply properties of radicals as well as properties of exponents. Notice that the radical expression in the numerator of this rational expression has an index of 4. The radicand is x cubed y. The denominator of this radical expression is the denominator of this rational algebraic expression is a radical expression whose index is 4 and the radicand is xy raised to 5. And we see that the numerator, the radical expression in the numerator and the radical expression in the denominator have common index of 4. Therefore, this ratio of two radical expressions can be written as a single radical expression by using the last property of radicals that I have written earlier here. And this is equal to the radical expression with index of 4, because 4 is the common index of the radical expressions in the numerator and denominator. And the radicand is the ratio or the quotient of the radicand in the numerator, x cubed y. Divide by the radicand in the denominator, xy raised to 5. To simplify the radicand, x cubed y divided by x times y raised to 5, we apply properties of exponents. And one property is we have a ratio up to exponential notations with common base of a, and this can be simplified, or this is equal to the common base a, and the exponent of a is the difference of the exponents, beginning with the exponent of a in the numerator minus the exponent of a in the denominator. We apply this property of exponent to simplify x cubed divided by x. The common base is x. First, we write the fourth root. The fourth root of common base is x. And according to this property of exponent, we get the difference of the exponents of x, beginning with the exponent of x in the numerator, 3, minus the exponent of x in the denominator, 1. 3 minus 1 here is 2. Multiplied by y. Common base is y, and we get the difference of the exponents of y. Exponent of y in the numerator is 1, minus the exponent of y in the denominator is 5. 1 minus 5 is negative 4. Now we simplify this further by now using a property of radical. The first property of radical that I have stated earlier. The nth root of a to the m to simplify this further, we apply this first property of radical. The nth root of a raised to m equals a to the power m over n, where the denominator n here is the index of this radical expression. First, I will write this as the fourth root, I will take x squared multiplied by y raised to negative 4 as one quantity. Raised to exponent 1. Now, comparing this radical expression with this radical expression, the index n is 4, the base a is x squared multiplied by y to the negative 4, and the exponent 1 here is m. Now, we write this radical expression in this form, in exponential form, where the exponent of the base is a rational number, or a has a rational exponent. Now this is equal to the base x squared y to the negative 4 to the power m. M is the exponent of the base. The exponent of the base is 1. Divide by n. N is the index of the radical sign. The index here is 4. To simplify this further, we apply property of exponent that says AB raised to n. We apply this property of exponent. The product AB raised to n is equal to the product of A raised to n multiplied by B raised to n. Each of these factors A and B is raised to the power n and multiplied. And we apply this property to this expression, exponential form. This is now equal to x squared raised to 1/4 multiplied by y to the negative 4 raised to 1/4. To simplify each factor, we again use a property of exponent that says a to the n multiplied raised to another exponent m is equal to a raised to the product of the exponents n and m. By this property of exponent, x squared raised to 1/4 is equal to x with exponent equal to 2 multiplied by 1/4 is 2/4. Multiplied by y raised to the product of the exponents. Negative 4 multiplied by positive 1/4 is negative 4/4. Or x raised to 2/4 to lowest term is 1/2. And negative 4 divided by positive 4 is negative 1. Hence, y to the negative 4/4 is equal to y to the negative 1. Now, it is customary that we get rid of negative exponents in the final answer. Or the final answer should not contain negative exponents. Hence, to remove the negative exponent of y, we apply another property of exponent that says 1/a to the power n is equal to a to the minus n. We apply this property of exponent to get rid of the negative exponent of y. If we want to remove the negative exponent of a, we bring it to the denominator. And we take the opposite sign of the exponent of a. We bring this in the denominator, the opposite sign of negative is positive. Hence, a to the negative n is equal to 1 over a to the positive n. And x raised to 1/2 cannot be simplified further. So we write that in radical form using this property. Or this property. We write x raised to 1/2 in radical form using this property. But we start now from the right hand side. A raised to m over n is equal to the nth root of a raised to m, where m is 1 and the denominator n is 2, which becomes the index of the radical sign. And to remove the negative exponent of y, we apply this property of exponent. 1 over a raised to n equals a to the negative n. Hence, x raised to 1/2 is equal to, by this property, is equal to the square root. The denominator n is 2, which means that the index of the radical sign is 2, and the index 2 means square root, or indicates square root. Square root of a to the m. Our a is x and m is 1. So square root of x raised to 1, but if the exponent of the variable is 1, we no longer write the exponent 1. So x raised to 1, we simply write as x. And we bring y to the negative 1 to the denominator by this property, and we take the opposite sign of negative 1. It becomes positive 1. So we bring this in the denominator, divide by y raised to 1. But again, we no longer write the exponent 1 of y. We simply write y. Hence, this given radical expression simplifies to square root of x over y. We take another example for simplifying algebraic expressions containing radical expressions using properties of radicals and properties of exponents. Consider this radical expression. We have the cube root of 27x cubed y raised to 12 divided by x minus y. To simplify, we apply the third property of radical. We have the nth root of a To simplify this radical expression, we apply this third property of radical that says the nth root of a divided by the nth root of b is equal to the nth root of a over b. That is, if you have a ratio of two radical expressions with a common index n, although with different radicands. This ratio of two radical expressions with common index n can be written as a single radical expression where the index of the radical side n is the common index of the radical expressions in the numerator and denominator, and the radicand is the quotient of the radicands in the numerator and denominator. But in this example, we will simplify this by starting from the right hand side instead of starting out from the left hand side. So we write the cube root of 27x cubed y raised to 12 over x minus y as a ratio of two radical expressions. The index n here is 3. Our a is 27x cubed y raised to 12. And our b is x minus y. Hence, by this property of radical, the given now is equal to the cube root of the numerator 27x cubed y 12 divided by the cube root, n is 3, cube root of the denominator, b. Our b is x minus y in the given radical expression. Now, by inspection of this, the cube root of x minus y cannot be simplified further because x minus y taken as one quantity has an exponent of 1, and 1 is not divisible by the index 3. But the radical expression in the numerator can be simplified further because the exponent of x, 3, is divisible by the index, as well as the exponent 12 of y is divisible by the index. And also 27 can be written as a cube of 3, or 27 can be written as 3 to the power 3, and the exponent 3 is divisible by 3. Hence, we simplify the numerator by using properties of radicals and exponents. As I mentioned earlier, the denominator of this rational expression, the cube root of x minus y, cannot be further simplified because x minus y taken as one quantity with exponent of 1, the exponent 1 is not divisible by the index 3. So we will simplify the numerator because the exponents of x and y are divisible by 3. 3 is divisible by 3, 12 is divisible by 3. Also, 27 can be written as 3 to the power 3, and the exponent 3 is divisible by 3. We take 27 times x cubed times y raised to 12 as one quantity raised to exponent 1. Now we apply the property of radical. The first property, the nth root of a to the m is equal to a to the power m over n, where the base a is 27 x cubed y raised to 12. The cube root of 27 x cubed y raised to 12 to the power 1 is equal to the base 27 x cubed y raised to 12 raised to exponent, rational exponent whose numerator is equal to the exponent of the base 1. And the denominator of the rational exponent of this expression of this base is the index of the radicals times 3. Divide by cube root of x minus y. We now apply property of exponent. The 27x cubed y raised to 12 is raised to 1/3. We raise 27x cubed y raised to 12 to the exponent 1/3. Hence, 127 times x cubed times y raised to 12 raised to 1/3 is equal to 27 raised to 1/3. Multiply by x cubed raised to 1/3. Multiply by y raised to 1/3. Multiply by y raised to 12 raised to 1/3. All over cube root of x minus y. Again, I said earlier that 27 can be written as a cube of 3. And we now write 27 as 3 raised to 3. That's 27 raised to 1/3. And we apply property of exponent to simplify x cubed raised to 1/3. The property says we multiply the exponents 3 and 1/3. Hence, x cubed raised to 1/3 is equal to x raised to the product of the exponents 3 and 1/3. 3 multiplied by 1/3 is 1. And we apply the same property of exponent to simplify y raised to 12 raised to 1/3. We multiply the exponents 12 and 1/3. And y raised to 12 raised to 1/3 is equal to y raised to the product 12 multiplied by 1/3, that's 12 over 3. Over the cube root of x minus y. To simplify this factor 3 cubed raised to 1/3, we apply property of exponents. The same property we apply to simplify this factor and this factor. We multiply the exponents 3 and 1/3. Hence, 3 cubed raised to 1/3 is equal to 3. Raised to 3 multiplied by 1/3 is 3 over 3 or 1. If the exponent is 1, we no longer write the exponent 1, we simply write 3. And the same with x. Instead of x raised to 1, we simply write x. 3x multiplied by y raised to 12 divided by 3 is 4. Divide by the cube root of x minus y. Hence, this is the simplified form of the given rational expression. Now, for your practice, please do the following exercises. The instruction is simplify. To simplify is to apply the properties of radicals and properties of exponents. Number 1, we have the cube root of x squared y cubed multiplied by the cube root of x raised to 4y squared. Number 2, we have the square root of 25 multiplied by m raised to 5 multiplied by n raised to 4. Number 3, we have a rational expression whose numerator and denominator are radical expressions. We have the square root of quantity x minus 1 multiplied by y cubed divided by square root of quantity x minus 5 to the power 5 multiplied by y. Number 4, we have the fifth root of y to the power 16 multiplied by z to the power 35 divided by 32 multiplied by x to the power 11. Now, there can be more than one way to simplify these algebraic expressions, but whichever way you should be able to get the same answer, simplified expression. And for you to check your answer, I gave you the answers to these problems. For number 1, the answer is x squared multiplied by y multiplied by cube root of y squared. Now, cube root of y squared cannot be simplified any further because the exponent 2 of y is not divisible by the index 3. For number 2, the answer is 5 multiplied by m squared multiplied by n squared multiplied by square root of m. The exponent of m here is 1 and 1 is not divisible by the index 2. The square root indicates that the index is 2. In number 3, the answer is y squared over the square of quantity x minus 1. Or using property of exponent, this can be simply written as the square of y over x minus 1. And for number 4, the answer is y cubed multiplied by z raised to 7 divided by 2 multiplied by x squared multiplied by the fifth root of y over x. That completes our lesson for today on properties of radicals. If you have questions about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalisan, the channel of learning and pleasure. Or you may ask your friends and classmates to subscribe to my YouTube channel, Art Kalisan. Thank you for being in my class today, and I hope to see you in the succeeding lessons.